All right, now let's start. So since none of you were there in the previous class, I discussed about what a differential equation is. Then I told them the order and degree of a differential equation. Then I discussed about the formation of a differential equation. And also we did a variable separable form of differential equation. All right. Okay. So Vedant, can you tell me the order and degree of this differential equation? Vedant?
Sir, order 2 and degree 4.
Order 2 and degree 4. Very good. Rakshit? What is the order and degree of this differential equation?
Order 2, sir. Degree 1.
Think again. Madhukar? Girish?
Yes, sir.
What is the order and degree for this differential equation?
2, sir.
See, order 3. It is there because it has been differentiated 3 times. And in such cases, degree is not defined because derivatives are not in their polynomial form. Got it?
Yes, sir.
Now, and that's it. Then we have done some questions like this. So today we will start with homogeneous form of differential equation. All right. So what is homogeneous form? First of all, let's understand. In an equation, in an equation, if you replace x by lambda x and y by lambda y. In an equation, if you replace x by lambda x and y by lambda y, and you are getting something like f of lambda x lambda y is equals to lambda to the power n f of xy. Got it? Then we call it homogeneous equation of homogeneity n. Got it? For example, if you have, say, f of xy is x square minus xy. Now you replace x by lambda x and y by lambda y. So what do you get? F of lambda x comma lambda y is lambda square x square minus lambda square xy, correct? Now take lambda square common, you get x square minus xy. So this came what? That is lambda square into f of xy. So since this lambda square came outside, this is a homogeneous differential equation of degree 2. Am I clear? So this is the homogeneous differential equation of degree 2. Now, can you tell me whether the function is homogeneous or not? And if it is, what is the degree? Tell me quickly.
Sir, can you explain one more time what is homogeneous mix? What is
Homogeneous
homogeneous?
is like if you replace x by lambda x and you replace y by lambda y. Got it? Then you get something like this. F of lambda x lambda y is lambda to the power n f of xy. Correct? So f of lambda x, lambda y became what? Here if you replace lambda square x square minus lambda square xy. Take lambda square common. It is x square minus xy. So lambda square xy. Got it? So here what did I get? F of lambda x, lambda y is lambda square f of xy. Now try for this one. This is, if you see carefully, this is definitely non-homogeneous. Because if you replace x by lambda x and y by lambda y, then f of xy will be, numerator will become lambda square xy, denominator mein it will be lambda x plus lambda square y square. Now one lambda gets cancelled out, but it cannot be written as lambda times f of xy or lambda to the power any, lambda to any power. You cannot write it like this. Getting my point? So this is not homogeneous. As simple as that, the degree of numerator should be equal to the degree of denominator. Its function is in this form. Got it? Now, what is a homogeneous differential equation? So when a differential equation in the form of this, dy by dx is f of xy upon gxy, where fxy and gxy are homogeneous function in xy of same degree. Both should have same degree, f of xy and gxy. They both are homogeneous functions and of same degree. Then we call it a homogeneous differential equation. And we can solve it by using a simple substitution, y equals to vx. Now what I will do, I will differentiate it with respect to x. Differentiate with respect to x. So dy by dx is v plus x dv by dx. Got it? Am I clear? See, one question we will do, then I will be able to make you understand in a better way. First of all, I write it 1 plus 2 e to the power x upon y dx is minus 2 e to the power x upon y 1 minus x upon y dy. Got it? So let's make it. Sometimes you may have to use substitution like x equals to vy. In that case, dx upon dy is replaced as v plus y dv upon dy. Yes or no? So from there, if you see, I will write dx upon dy because see, everywhere in the question they are using x upon y. I can even solve it using y equal to vx, but that would be much difficult. Because everywhere in place of x upon y, you will have to replace 1 by v. So better we change the question into dx upon dy. So dx upon dy is what? Minus 2 e to the power x upon y, 1 minus x upon y upon 1 plus 2 e to the power x upon y. Now replace x equals to vy. See very carefully. So dx upon dy is v plus y dv upon dy. Now replace it here. V plus y dv upon dy is minus 2 e to the power v into 1 minus v upon 1 plus 2 e to the power v. Am I correct? Now take this v to the right hand side. So y dv upon dy is minus 2 e to the power v plus 2v e to the power v upon 1 plus 2 e to the power v minus v. Got it? If you take LCM, minus 2 e to the power v plus 2v e to the power v minus v minus 2v e to the power v. Now they are cancelled. So y dv upon dy is minus 2 e to the power v minus v upon 1 plus 2 e to the power v. Am I clear? Just have a look at this much first. Have a look. Now we got this. Now use the variable separable. So 1 plus 2 e to the power v upon, take minus common, 2 e to the power v plus v dv is dy upon y. Now integrate both sides. In the left side, if you see, the derivative of denominator is there in the numerator. So answer will be what? Minus ln of denominator. So 2 e to the power v plus v is ln y plus constant. Now we replace v again by x upon y. So minus of ln 2 e to the power x upon y plus x upon y plus ln y plus constant. This is how we do it. Bishan? Bishan? Did you get this? Bishan, did you get this? Vedant?
Yes, sir.
Understood?
Yes, sir.
Chalo, shall we go now? Now, is the solution required? See, equation reducible to homogeneous form. I do not find it of too much of importance, and rare of the rarest cases there where you will find its question in any exam. So I will skip it as of now. Got it? So This is fine. Just a moment, just a moment. You just try this question. Form a differential equation having y equals to sine inverse x square plus a cos inverse x plus b where arbitrary constant. So we'll do it later on. But to now we will do linear differential equation. This is the most important form of differential equation. Am I clear? Linear differential equation. So without talking too much about things, but let's go directly to the kind of differential equation it will look like. It will look like this. dy by dx plus py is equals to q. dy by dx plus py is equals to q is linear differential equation in y. Okay, where p and q will be either constant or function of x, where p and q are functions of x only, or they can be constants or constants. Now there comes into picture a term what we call integrating factor. Got it? So integrating factor will be what? E to the power integration, whatever the coefficient of y you are getting, whatever the coefficient of y you are getting, p dx. Got it? So integrating factor is e to the power integration p dx. And now after calculating this integrating factor, the differential equation will be like y into integrating factor is equals to integration q into integrating factor dx plus constant. This will be the solution of these kind of linear differential equations. There is a reason behind it why it is so, but if we go into too much of depth, it will be a little risky for you guys. So let's not dig into too much. Just simply understand how to solve a linear differential equation. Will you be able to remember it? Now, sometimes what it will happen, differential equation will be of this type. That means independent and dependent variable are exchanged. X is replaced by y and y is replaced by x. So it is dx upon dy plus px equals to q. Dx upon dy plus p1x equals to q1. Now here these p and q, yeah, p1 or q1 will be constants or functions of y. Got it? So solution will be what in this case? X into integrating factor is integration q into integrating factor into dy plus constant. Am I clear? Now you will get more clarity if we solve a question. See, this is a question. dy by dx plus some function of x into y equals to some another function of x. So this form is dy by dx plus py is equals to q. So the first task is integrating factor. So integrating factor will be e to the power integration p dx. Now p is what? 3x square upon 1 plus x cube dx. Now just simply integrate it. So derivative of denominator is written there in the numerator. So answer will be what? E to the power ln of denominator. Am I correct? And you also know a fact that e to the power ln of p or anything, ln of say r it will be r. E and log will cancel out. So it will be 1 plus x cube. Just a moment. Got it? Am I clear? Now solution will be what? Y into integrating factor, that is 1 plus x cube is equals to integration of q. Q is what? Sine square x upon 1 plus x cube into integrating factor 1 plus x cube dx. Am I correct? Now this 1 plus x cube cancel. So y into 1 plus x cube is integration of sine square x dx. That is 1 minus cos 2x upon 2 dx. Correct? Now you know how to integrate. So y into 1 plus x cube is 1 by 2 integration is x by 2. Cos 2x by 2 integration is sine 2x by 4 plus constant. This is the solution of your differential equation. Everybody understood? Now complete it quickly so that we will move forward. Got it? Everybody understood? Rakshit? Rakshit? Vedant understood?
Yes, sir.
Now try this one on your own quickly. X ln x divided by dx plus y is equals to 2 ln x. Go for it quickly. Quickly try, guys. See, this is dy by dx plus 1 upon x ln xy is equals to 2 by x, isn't it? This will be the differential equation. So first of all, if you talk about integrating factor, that would be e to the power integration 1 upon x ln x dx. So if 1 upon x ln x, I can write it like 1 by x upon ln x dx. Now derivative of numerator is there in the denominator. Derivative of ln x is equals to 1 by x. So answer will be what? E to the power ln of ln x. And this will be finally ln x. So this is your integrating factor. Now solution will be what? Y into integrating factor, y into ln x is equals to integration of q, that is 2 ln x, into integrating factor ln x dx. That is 2 integration ln x whole square dx. Now we will use by parts to integrate it. Assume 1 as first function. So first ln x square, integration of second is x minus integration first derivative. So it is 2 ln x upon x, integration of second x dx. X cancel. So it is 2x ln x square minus 4 times integration of ln x dx. And integration of ln x is what we remember from so many days. That is x ln x minus x. So it is 2x ln x whole square minus 4 times x ln x minus 4x. So it will become plus 4 plus constant. So this will be your solution. So solution is what? Y ln x is equals to, take 2x common, ln x whole square minus 2 ln x plus 2 plus constant. This is your general solution of this differential equation. This is your general solution of this differential equation. Q is, okay, Rakshit is saying Q is 2 by x. I divided by xl and x. I made a mistake. I took Q from there only. All right. See, no problem. We will change it. So now the question became more simple even. So answer will be 2 ln x upon x dx. Now you substitution, take ln x as t and 1 by x dx will be dt. So answer will be 2 times ln x whole square by 2 plus constant. So answer will be y ln x is ln x whole square plus constant. Thank you. Thank you, Rakshit. Am I clear now? Chalo, anyways, this was easy treat. Now, forms reducible to linear. See, forms reducible to linear, let us not talk about anything too much about this. And we call it Bernoulli's equation. So we will directly jump to question and learn from that. Okay? Let's not decide and get into any strategy. So things may change here with respect to every problem differently. Like take this question only. Take this question. Got it? So how do I approach this question? First of all, divide this differential equation by sin x, 2 sin x. So you get dy by dx minus y cos x upon 2 sin x is equals to x e to the power xy cube upon 2 sin x. Got it? Now divide this equation by y cube also. So you get 1 by y cube dy by dx minus 2 cot x into 1 by y square equals to x e to the power x upon 2 sin x. This is it. Now what you will do, you will assume 1 upon y square as t. So minus 2 upon y cube dy by dx will be dt by dx. Now replace this 1 by y cube dy by dx as minus 1 by 2 dt by dx minus 2 cot x into t equals to x e to the power x upon 2 sin x. And finally multiplied by minus 2. So you get dt by dx plus 4 cot x into t is equals to minus of x e to the power x upon sin x. Am I clear? Now we will use that Bernoulli form and do it. What means Bernoulli result? Now it's a simple linear differential equation question. Got it? Now you guys try this one. This is very simple question. Have a look and give it a try. Yes. Mission done. Rakshit. Now see. Again the same thing. To maintain the coefficient of x, a function of x only in the right side, I divide the equation by y square. So 1 by y square dy by dx minus 1 by x into 1 by y is 1 by x square. So now, first of all, replace 1 by y as t. So minus 1 by y square dy by dx will come as dt by dx. Am I correct? So minus of dt by dx minus 1 by x into t is 1 by x square. Got it? Now multiply this equation with a negative sign. So dt by dx minus plus 1 by x into t is minus 1 by x square. Now if you find integrating factor, it would be e to the power integration 1 by x dx. That is e to the power ln x, that is x. So solution will be t into x is equals to integration q. Q is minus 1 by x square, then integrating factor is x dx plus constant. 1x cancels here. So tx equals to minus of ln x plus constant. And then your t is what? 1 by y. So answer will be x upon y is minus ln x plus constant. Am I clear? Madhukar? You see the same solution they have given. Madhukar, did you get it? Anyways, concept test. Find the solution of the differential equation. All right, over to you guys. 5 minutes you got, solve it quickly. Quickly do it. Now see. Again you divide it by y square first of all. So what do you get? Dy by dx 1 by y square minus 1 upon y into tan x is minus of secant x. Now in 1 by y ko let us assume t or take minus 1 by y as t. So 1 by y square dy by dx will be dt upon dx. So dt upon dx minus plus t into tan x is equals to minus of secant x. Now you got it. Now integrating factor will be what? E to the power integration of tan x dx. Integration of tan x is ln sec x. So it is e to the power ln sec x. E ln cancel, it will become secant x. So solution will be t into integrating factor is equals to integration q, that is minus sec x, into integrating factor sec x dx. So it is with the negative sign secant square x, that is 1 plus tan square, sorry, secant square x, keep it secant square x only. And integration of secant square x is what? Tan x. So it is minus of tan x plus constant. Now t replaced by y. So secant x upon y is minus of tan x plus constant. Am I correct? Have a look. Now, there comes a topic, trajectories. Trajectories is what? A curve which cut every member of a family of curves according to a given law is called a trajectory of the given family. Trajectory is simply like a path. A path, a like route. Okay? So a curve which cut every member of a given family, a curve which cuts every member of a given family of curves according to the given law is called trajectory of the given family. The trajectory will be called orthogonal if trajectories cut each member of the given family at right angle. Orthogonal stands for right angle. Got it? So orthogonal stands for right angle. Okay, so this is what we call orthogonal trajectories. So what is the working rule? How to find the orthogonal trajectory for a given family of curve? First of all, like a family of curve is given. A family of curves is given. Then form the differential equation of that family of curves. Form the differential equation of that family of curves. Now orthogonal means what? Perpendicular. So what is dy by dx is what? Basically slope. So perpendicular slope will be minus of dx upon dy. Got it? Now write dy by dx as minus of dx upon dy. Don't do this. This is fine. So for dy by dx, replace minus 1 upon dy by dx or minus of dx upon dy. Now solve the new differential equation and the curve, the family of curve you are getting is what we call the orthogonal trajectory for the given family. Orthogonal trajectory for the given family. Just a moment, guys, have a look at it. Hello? Yeah, got it? So replace dy by dx as minus 1 upon dy by dx. That's it. And then solve the differential equation you obtain, and that would be the new family of curve. Got it? Now this is like we have a question, find the orthogonal trajectory for a family of straight line passing through the origin. All right. So first of all, find the original curve they are saying, that is straight line passing through the origin. So that would be y equals to mx. Now form differential equation. So if you differentiate it, dy by dx as m. So the differential equation you get as y equals to dy by dx into x. Got it? Now replace dy by dx as minus of dx upon dy. So y is minus of dx upon dy into x. So it will be y dy is minus of x dx. So it is simply what? Variable separable, then integrate it. So this is y square by 2 is minus of x square by 2 plus constant. So x square plus y square equals to 2 constant. So this is the orthogonal trajectory. That means now you can correlate every line which is passing through the origin is orthogonal to the circle with center at origin. Like if you see any line which is passing through the center will always be the diameter, and that will be orthogonal to the given curve. Am I clear? So this is what we call orthogonal trajectory. So that would be all, guys. This is all for today. Now you practice more, do it more, and practice questions from anywhere, whatever the source you have. Even NCERT exemplar is a very good source to practice. All right. Now I would like to ask you for a small feedback about this class. So just mention that, and then you will be free to go.